All right, so yesterday we were working on composite functions with our trig functions, right? So today we're going to do exactly the same thing. We're going to continue to work on inverse trig functions and composite functions, but we're now going to include the other three that we haven't dealt with: secant, cosecant, and cotangent. Specifically, arcsecant, arccosecant, and arccotangent. So the inverses of those. Secant is the inverse of who? Cosine, yes, sorry. I thought I heard it and then whatever. My ears are only so good. Sorry, not inverse. Secant is the reciprocal of cosine. So when I'm thinking about where I'm allowed to look for these angles, it's exactly the same for secant as it is for cosine. Where on the unit circle am I allowed to look for angles for cosine? Top half, quads 1 and 2, right? That's where I'm allowed to look for secant also. Where on the unit circle are we allowed to look for angles for sine? Right half, 1 and 4, right? So that's exactly where I'm allowed to look for, who's the reciprocal of sine? Cosecant. So for arccosecant, I'm allowed to look at 1 and 4, just like with arcsine. Arccotan is odd man out. Do you remember why we had to stay in between negative pi over 2 and positive pi over 2 for tangent? What's tangent of pi over 2? Undefined. What's tangent of negative pi over 2? Undefined. So we had these boundaries. That's why I had to stick in between 1 and 4 for arctan. Where is cotan undefined? At 0 and at pi, right? Cotan is undefined on the opposite ones that tangent is. It's not these two, it's these two. So for arccotan, if I have to stick between 0 and pi, where am I allowed to look? 1 and 2, top half. So arcsecant does exactly what arccosine does. Arccosecant does exactly what arcsine does. Arccotan is a little bit weird, but that's because of where cotan is undefined. So far, so good? All right. Let's practice with these guys. What do inverse functions find again? Yes. This is going to find the angle. So I'm thinking to myself, where is secant of some angle equal to negative 2 radical 3 over 3? This is what I'm asking myself in my head as I'm trying to answer this question. I probably should narrow down what quadrants I'm even allowed to be looking at. For arcsecant, got it. For arcsecant, I'm only allowed to look where? First, and I'm sorry, I didn't hear the other word you said. Secant is the reciprocal of who? Cosine. If secant is the reciprocal of cosine, 1 and 2. Is this angle going to be in quad 1 or in quad 2? How do you know? Because it's a negative. No matter which inverse function I'm talking about, if it's positive, it's always going to be quad what? Quad 1. If it's a positive ratio, I'm in quad 1 no matter what. All right, so I know I'm looking in quad 2. I'm not as good with my secants and cosecants as I am with my sines and cosines around the unit circle. Are you guys okay if we flip this over? This is the same question as saying cosine would be negative 3 over 2 root 3. If I rationalize that denominator, what is this going to be equivalent to? Negative square root of 3 over 2. You guys following how I'm getting there or no? Because I'm happy to break it down more if I need to. So where is cosine negative radical 3 over 2? Pi over 6. Did I say that right?
Yeah, 5 pi.
5 pi. I missed the 5 part. 5 pi over 6. How are we doing? Okay. Let's look at our inverse sine. Yes. This is going to find the angle. For sine, I'm only allowed to look in which places? Sine can look in 1 and 4. Is this one going to be in 1 or in 4? 1, because it's positive. So where is sine theta equal to 1/2? Pi over 6. What question am I asking myself on number 3? Yes. Where is cosine equal to negative 1/2? Where am I allowed to look for this? 1 and 2. Will this angle be in quad 1 or quad 2? Quad 2. So in quad 2, where is cosine equal to negative 1/2? 2 pi over 3. So far, so good? Clear as mud? Mud isn't very clear. Where is tangent theta equal to negative radical 3 over 3? But I'm looking in which quads? 1 and 4. And Ibrahim, you said I'm looking where? Quad 4. Because? It's negative. So here's the thing about quad 4, and I know we talked about this yesterday. If I'm in quad 4, what's weird about my angles?
That you don't have your the 11 over 6 and 7 over 4. You have the same that at the top of the numerator.
Yes. Got to do the negative angles here. So I know my answer to this is a negative something. And tangent is what over what? Sine over cosine. Okay, so I'm going to unrationalize that numerator for a minute. So this would be the same as negative 1 over radical 3. So thinking about my sine and my cosine values, I want sine to be a negative 1/2, and I want cosine to be a positive root 3 over 2. Negative pi over 6. That I wrote in the denominator?
Yeah.
So when I'm thinking of sine over cosine, all the way around the unit circle, if it's not a whole number, it's all over 2.
Okay.
We normally cancel it out when we're talking about tangents, but because I don't know my tangent around the unit circle as well as I know my sine and my cosine, I'm trying to think of them as sine over cosine. I want you guys to try 5 and 6 on your own, and then we'll look at a couple more examples. Does anybody have an answer for number 5? Is it what? It is not pi over 3. It is pi over 6. Let's go through why. First of all, where am I allowed to look for cotan? 1 and I'm never allowed to look in 3. 1 and 2. Because where is cotan undefined? 0 and pi. So I have to stay between 0 and pi. That's why I'm looking at the top half. Is it going to be in 1 or is it going to be in 2? 1. Because we have a positive value here. I'm going to turn this guy into a fraction because I know that cotangent is what over what? Cosine over sine. And around my unit circle, all my sines and cosines are over what? Over 2. So I'm looking for, where is cosine? Root 3 over 2. Where is sine? 1/2. And that happens at pi over 6. So far, so good? Did anybody get a final answer for number 6? Pi over 4? Pi over 4. Secant. Where am I allowed to look for secant? 1 and 2. This guy's positive, so I know it has to be in quad 1. So I'm asking myself, where is secant of theta equal to radical 2? Or where is cosine theta 1 over radical 2? Well, if I rationalize that denominator, I see my radical 2 over 2, and I know that means I'm looking at my pi over 4s. You guys okay with that? Do you have a question?
Yeah. Okay, so you know how you use cosine for secant, and how come you didn't do that for
For cotan? I could have. I could have looked at tangent, but the reason that I don't usually go there in my mind is I personally don't know my tangents around my unit circle as fast as I know my sines and cosines around my unit circle. So I think of cotan as cosine over sine so that I can find those values off my unit circle a little bit faster. Does that help? Okay. There's more than one way to go about thinking through these. I try to share the things that work for me, but that's not always what works for everybody. So if what I'm doing up here doesn't work for you to understand, we can come at it from a different way. Just let me know. I'm going to put up 6 more examples like this. I'm going to give you guys about 5 minutes on your own with these 6. I want you to tell me where those angles are. All right. Number 7. What do we get? Pi over 3 is correct. Who wants to see that one? Sounds good. Okay, so what quads am I allowed to look in for cosecant? 1 and 4. And I know I'm in quad 1 because it's positive. Okay, so where is cosecant theta equal to 2 radical 3 over 3? That's the question I'm asking myself. Or, because I'm not as good with my cosecants, where is sine equal to the reciprocal of that, 3 over 2 radical 3? Well, if I rationalize that denominator, that's the same as what? Radical 3 over 2. So sine is radical 3 over 2 at pi over 3. Does that help? What about number 8? Negative pi over 2. Nice job. Thank you for not telling me 3 pi over 2. Why is 3 pi over 2 wrong? That goes outside of where I'm allowed to look. That involves going through quad 2 and through quad 3, which I'm not allowed to do. I have to stick in quads 1 and 4. This one has to be quad 4 because it's negative, but that means a negative angle. Yes?
Can you explain the rationalization for number 7 again?
Oh, absolutely.
Screw the 3 over 2.
Yeah.
I don't know how.
Yep. Let me scoot that out a little bit further. So I would multiply top and bottom by radical 3. So what that's going to mean is that in my numerator I have 3 radical 3, and in my denominator I have 2 times 3, right? And the 3's cancel. Instead of just multiplying those together, I leave them as their factors so that I can see what cancels. Does that help?
Yeah.
Cool. Number 9. Where am I allowed to look? 1 and 4. Where am I looking? Quadrant 4. So where in quadrant 4 is tangent equal to negative 1? Negative pi over 4. Remember, if you're in quad 4, because it's negative, your angle will be negative. That's not true for quad 2, but it is true for quad 4. All right. Number 10. Where am I allowed to look? 1 and 2. Where are we going to be? 1. So where is cotan of theta equal to radical 3 over 3? Pi over 3. Does anybody want to see that one? Okay. So first thing I'm going to do is unrationalize my numerator. Unrationalize my numerator. So that means it's going to be 1 over radical 3. And then because I'm thinking about cotan, I put both of these guys over 2 because I know that cotan is cosine over sine. So I'm looking for where is cosine 1/2, and at the same time sine is radical 3 over 2. Does that make sense? Anytime I'm talking about the tangents or cotangents and I've got that fraction set up, I always stick a little like over 2 with each of them so that I can think about my unit circle a little bit better. Number 11. Where am I allowed to look? 1 and 2. Where am I? 2. So where is cosine of theta in quad 2 equal to negative radical 3 over 2? 5 pi over 6. And the last problem like this. Cosecant. Where do I have to look? 1 and 4. Where am I? 1. So where is cosecant equal to 2? I'm not as good with my cosecants. I can turn it into sine, but then I got to make this the reciprocal, right? So where is cosecant equal to 2 is the same question as where is sine 1/2? Pi over 6. So far, so good? Cool. Let's do some composites now. Same thing we were doing yesterday. This is the only thing we did yesterday. We're just going to practice more with what we did yesterday. Whenever I have a composite function, I have to do what part first? Inside part first. So I'm looking inside. What type of function do we have on the inside? Inverse. Inverse functions find what? Yep, this is going to find an angle. For inverse cosine, I have to look where? 1 and 2. Which quad am I looking in? 1. So where in quad 1 does cosine have a value of 1/2? At pi over 3. So now I want the secant of pi over 3. So secant is the reciprocal of cosine, right? So secant is 1 over cosine. What's cosine of pi over 3? 1/2. So this is going to be 2. Which I'm pretty sure I heard several people tell me, but I just wanted to kind of walk through all those steps. Start inside. This is going to find what? It's going to find an angle, right? My inverse functions only find angles. Where is tangent equal to 1? Pi over 4. So this whole thing is pi over 4. And now I want cosecant of pi over 4. Cosecant is 1 over sine, right? What's sine of pi over 4? So I have 1 over radical 2 over 2. Or that's the same thing as 2 over radical 2. What happens when I rationalize that denominator? It just turns into square root of 2. Do you guys have any questions about number 1 or number 2 here? I want you to do number 3 on your own. What quad will my angle be in? Fourth quadrant. So where in the fourth quadrant, well, hold up. If I'm in the fourth quadrant, what do I already know about my angle? It's negative. So where in the fourth quadrant, thinking negative angles, is sine negative root 3 over 2? Negative pi over 3. So now I want to find cotan of negative pi over 3. Well, I know that cotan is cosine over sine. So I need cosine of negative pi over 3, and I need sine of negative pi over 3. What's cosine of negative pi over 3? What'd you say? 1/2. What's cosine of negative pi over 3? Yep, negative radical 3 over 2. So I can cancel those denominators, and then I need to rationalize my denominator, right? So what's my answer here? Yes, negative square root of 3 over 3. If I start inside the parentheses on number 4, am I finding an angle? No. That's sine of an angle. This is going to find me a ratio. Do we know sine of 5 pi over 4? What is sine of 5 pi over 4? Yes. Negative radical 2 over 2. My final answer is going to be an angle, because that's outside function, finds angles. What quads am I allowed to look in for inverse cosine? 1 and 2. Where will this one be? 2. Because it's negative. So where in quad 2 does cosine have a value of negative radical 2 over 2? 3 pi over 4. Cotan of 2 pi over 3. Well, cotan is cosine over sine. What's cosine of 2 pi over 3? Negative 1/2. What's sine of 2 pi over 3? Square root of 3 over 2. I'm going to get rid of those denominators. Do I have to rationalize this denominator? Is it my final answer? Then you don't need to rationalize it yet. You need to rationalize denominators on final answers. I want to know where tangent has a value of negative 1 over radical 3, or I can think about this as my sine and cosine values. Negative pi over 6. I'm only allowed to look in quads 1 and 4. Since it's a negative, I'm in quad 4, and that means a negative angle. I want you guys to do number 6, and then we're going to put up our last couple examples. What is sine of 7 pi over 6? I'm sorry, you said what? Negative 1/2. So only allowed to look in quads 1 and 2 for inverse cosine. Which quad will this be in? 2. Where does cosine in the second quadrant have a value of negative 1/2? 2 pi over 3. Fantastic. I've got 3 more problems and 3 more minutes. So let me pop those up. I'm also going to pass back your quizzes so you guys can see those, okay? I got yours done too. I know, right? Question though. Inverse trig functions find angles, right? Where on the unit circle does sine have a value of radical 2 over 3? Where on the unit circle does sine have a value of radical 2 over 3? Don't know where, which means I have to draw my triangle. Sine is what over what? Y over R. So I've got radical 2 here. I've got a 3 here. Once I find this, can I write cotangent for that triangle? Cool. I'm going to pass those quizzes back while you guys are doing this. And I'll put the answers up here in just a moment. Overall, I was pretty pleased with the scores. I will need to recollect these from you guys before you leave. So I still have one person that hasn't taken it yet. Give me just one moment. All right. I've got the answers for these 3 up. If you guys are interested in seeing the steps and how I arrived at those answers, I will have those posted on Canvas for you guys. Okay?